I do love some banter, but let's get some things done. So, so where were we? We talked about rebuilding. Oh, and yeah, that fucking that XQCD where it's like they're fighting because they're like, oh, it's compiling. Actually, like happened to me this Friday. I was coding some stuff, and it's like I recompile it. And it's like 6 files or something, and then all of a sudden, I must have saved the wrong file or something. All of a sudden, it was like recompiling 2,100 files. I was like, oh no. So then it's like, okay, that's an hour. So it's like grab a drink or take a walk or something. So that happens sometimes. Where it's like all of a sudden it's like, well, I guess I'll take a break.
It feels so insane that people just kind of accept that. It's like, why don't you make it better? Or like for the unreal people, I mean.
It's code. It's like, no language is ever gonna be able. I mean, C++ is pretty slow on compile times. It's not the fastest compiling language ever, but I mean, even if you work in any language, like if you have 2,000 files that needs to be recompiled, like it's gonna take a while. So that's not really something you can fix, really, unfortunately. All right, so let's go into our scene here. So we made our cool actor, and it's pretty cool. So, but however, if we actually try to put in a cool actor, as we said before, we have no components. So by default, it has no components. We have to like go in and add it ourselves, like manually, which is like, not the nicest thing ever. We might want to have it so it has components on it by default. So how do you do that in Visual Studio or in C++?
Are you screen sharing, by the way?
No.
I was about to ask.
Yeah.
I am not. Thank you. Open share tray. There we go. I should have said like, yeah, I'm screen sharing. What are you talking about? You should restart your computer, I think. I am recording as well. Okay, cool. There we go. Thank you for mentioning that. So, why do I have a screen? Oh, okay. It was I was like, why do I have a screen? It was like, just this guy. It's like, you're my favorite. Okay, so, yeah. I'm gonna remove the comments because they're in the way, actually. Be gone. So the way we do that is that we first of all have to create a variable to hold the component. So let's make a scene component. So a scene component, again, is just the most basic component you can have. Asterisk, kind of. There is one more basic, but let's not get into that later. It's the most basic component you have that can have a transform. So a scene component is essentially just a transform. It can move, it can scale, it can rotate, but it has no real other functionality other than that. So let's add that, and I'm gonna call it scene. That's a good name for it. There's gonna be a pointer, so I'm making a using component pointer. And then what you do is in the constructor. So this is something that's gonna be set up for the default class. So this is not, we're not gonna spawn it, when we like spawn the actor. We want it to be like sort of spawned as a default component. So we do that in the constructor, and what we do is that we call a function called create default subobject. So create default subobject. I'm actually not sure exactly what it does. You could probably use it for a lot of things, but one of the things it's used for is creating components in the constructor.
Just a quick question. So when you were describing using component before, would that make it in that case similar to game object in Unity?
It's kind of. You can see it as like an empty game object, with just a transform component. Yeah, it's a good point. All right, so we have a create default subobject, and it's a template function. Let's actually go take a look at it. This one wasn't great. Hold on. Oh my, Visual Studio's hang. Oh no. Okay, there we go. Here. This one is not great either. Here. Okay. So here's the function. So it's a template class that takes a return type. I don't know if this one is actually used. I think this one is implied. but this one is the important part. So we have to put in which type of component we want to create into this function, and then we give it a name. So what the components can be named in the editor. So let's do that. So let's go back. So I'll type u scene components. So we want to create a scene component. And then sub-object name is going to be the name of the component in the editor. So I'm just going to type text again, because we have to type text. We have to make sure this is a good string, and then I'll just call it scene root or something. So that's just what it's going to be called in the editor. All right, so let's see what happens. So I'll compile. It's taking its sweet time. Hello? We're like broken or something? Okay, I gave you a chance, you fucked it up, so I'm just gonna restart. So let's restart. See what happens. Okay, so there we go.
Love each time we have to restart it. You see, fuck.
I think that's very appropriate, actually. So we'll go into our cool map, and let's get rid of a cool actor and then spawn a new one. Okay, so there it is. However, there's some problems. First of all, we get this warning here. So it says, persistent cool actor 0 has natively added some components, scene components, but none of them were set as the actor's root component, picking one arbitrarily. What that means is we didn't put one component to be the root component, and we actually have to do that ourselves. We have to define which of our components that we're spawning in code is going to be the root, and now we just sort of picked one arbitrarily, and we only have one, so sort of pick the right one, but it's probably better if we can actually do that ourselves. So the way we do that, if we set a variable on the actor. So there's a variable on the actor called the root component, and we can use set that to be whatever root component we want. So I'm just going to set the root component to be scene. And then hopefully maybe this time it can compile. Okay, there we go. So now hopefully, let's see, cool actor. Now hopefully if I put this in, yeah, it doesn't complain. So now we have our root component here. Problem is that if I click it, I actually can't change anything. Like I can't click any of these. And of course, like there's not all that much important stuff going on here, but it would be nice to be able to change stuff, especially if it was like a mesh or something. And it says here, native components are editable when declared as a F property in C++. Okay, and what this means is that we have to define our variable holding this component to be a U property. So we have to say this variable that we're holding the component in, we want that to be visible to the engine. We want that to be visible for the editor. And to do that, we declare it as a U property. Like this. We use type U property, kind of like a meta tag, in front of the variable. No semicolon. No semicolon. So now we've declared it as a U property. And let's see if I recompile. Okay. So if I click the boy, cool actor, then okay, it's still giving me trouble. So the problem here is that it's not enough in C++ to just declare it as a U property. Now it is visible to the engine and to the editor, which is good, but it's not visible to the user. It's not we haven't declared that they can actually change stuff in here. And even more alarmingly, if I actually go in and inherit from this, if I make a blueprint class and I inherit from cool actor, so let's say I want to make a derivative of the cool actor to do some blueprinting. So I'll do BP cool actor. So now I made an inheritance from C++ into blueprint. then even more alarming, there's just nothing here. If I click the scene component here, this default root, then it's just empty. There's nothing here. So that's kind of alarming. So what we've done is we made a property, we made it exposed to editor, but it's not exposed to the user. And the way we fix that is that inside of these parentheses, we can put meta tags, or we can put specifiers, property specifiers. And there's a bunch of them. Let's actually Google. Let's Google Unreal property specifiers. There it is. So here are all the property specifiers that you can actually put into your view properties. There's like 1 billion of them that control certain behavior about how it's exposed to the engine, what you can do with it, like some metadata, if it should be a slider, you know, all of that stuff. And there's like 1 billion of them, but let's take the one we need right now. Here's some visible ones. So there's visible anywhere, visible defaults only, and visible instance only. Okay, so let's do visible anywhere for now. Let's just say like, okay, I want to show this everywhere. So I'll just do visible anywhere on here. So I'll add visible anywhere as a specifier for the U property. And in this case, you know, I've written it in front of the scene. So, you know, when the code, the analyzer comes in, it will say, okay, this scene component is a U property with specifier visible anywhere. Cool.
Emil, could I just stop you for a minute?
Yes.
Could you increase the text size, just zoom in a bit, because I'm getting some drops in quality and can't really see what you're writing sometimes. So
Of
could
course.
you zoom in? Yes, thank you.
Is that better?
Yes, much better.
Great.
Is visible anywhere like a bit tag? Like, can you do bitwise operations with it to include multiple tags, or?
It is a bit, yes, it is actually a bit mask, the specifier. So if I do visible anywhere and then I add something else, I add like, I don't know, transient. You don't do them yourself. Like you used to separate with a column, like this, to add more specifiers. But in the engine, they are stored as a bit mask. Yes.
Cool.
Great. So now we have a visible anywhere specifier. So let's compile. Maybe it will work, maybe not, who knows? I remember when I had this course in the beginning, actually, some people defied me. They defied me and tried to use recompile, even though I told them it doesn't work. And then they would be like, nothing works, it gives me weird errors. And I was like, did you use recompile? And they're like, no, I swear, teacher. And I was like, I know you use recompile, I can see it, your guilty eyes. So yeah, it's scary. So anyways.
How is it you do recompile?
Sorry?
How is it you do recompile?
Use the hot compile, I mean. Instead of just restarting the engine fully. So now that we have a U property that's visible anywhere, now you can see I can actually go in here and change, you know, the scene components. I can do auto-activate this editor only or whatever. Very cool. Not very useful for the scene component. It's quite barren. But, you know, if this was a static mesh, we probably want to go in and set the mesh or something. The same thing in here. If I go into the derivative actor, I can now also see the scene component when I actually click it in the inspector here. Very cool. Great. So that's a component, and let's actually add a mesh as well, so we can see it in the world. Because if I play now, we only have a scene component. A scene component has no rendering. It's only a transform. Damn, that pizza looks fucking great. It only has a transform, so we might want to see it actually in the world, so we can interact with it. So let's add a static mesh to it as well. So I'm going to code, and I'm gonna add a U static mesh component. I had to think for a second. Use static mesh component. I'll call it mesh. So I'll make that a U property, and I'll make it visible anywhere as well. So let's put that in right away. And then I will go into the C++ file, and I will set up I'll actually do it on here. I will set up the mesh as well. So mesh is equal to create default subobject U static mesh component text mesh. So I'm creating a use static mesh component. I'm calling it mesh, which means that in the editor it will come up as the name mesh, and I'm saving it into the mesh variable here. Okay, so let's see what happens. Compile. Oh, fantastic. So if I go into cool actor here, there we have it. We have our mesh. Now, a thing that I was hoping it wasn't gonna work because there's actually one step we need to do as well. There's some setup needed for scene components to make sure that their parent is set correctly and that their attachment is set correctly. It seems like it did that automatically. It just attached it to the root component. But there is a step here that we kind of need to do to make sure this is initialized properly, and that's called mesh setup attachment. And setup attachment does all of the important things, it initializes the static mesh or initializes the component properly. And it also lets us decide what its parent should be. So we're saying, like, I want it to be attached to, you know, what have you. If you want to make a mesh and then another mesh and attach one to the other, that's where we like put in which way this should be parented here. So I'm just going to set in the root component as the parent. Nothing super special. Unfortunately, it didn't scream at me. Sometimes it does. Sometimes it's like, you didn't call setup attack for you crazy! But apparently it didn't do this time, so that's too bad. But yeah, this is important. Don't forget this. Or bad things will happen. Sometimes you get like components that aren't initialized properly and they have weird values and everything goes wrong. Okay, so now we have a mesh. So if I go into the game, check up on, there it is. We have a mesh, however, it's not set to anything by default. So like this is none. So we have a static mesh component, but it has no mesh asset tied to it. So if I click this here, you can see all the assets I could put it in. So if I put like a sphere, I don't think that was a good sphere to take. That was like a fog wall. You'd like to take another one. Let's do a shape cylinder. Hello? Okay, this is probably...
What's going on with your screen right now?
What?
Yeah, like an overlay of code. I don't know.
Yeah, you had this problem with your camera before, but right now your code is
Oh.
It was like a fucking CRT scan-in over the Unreal Engine that you're messing around with, but now it's fixed.
What the fuck? Okay.
Yeah, and the Unreal Engine also lost all color.
I only saw like an overlay of your previous code in different colors on the screen.
Is it
I have no
like...
idea.
It's just OBS being dumb.
Oh, you think it's OBS?
I think so, yeah. It's fine. It's fixed now.
Okay, let me know if it happens again, and I'll like take a break or something to fix it. Okay, so it's not showing up, and I am guessing this has to do with we didn't do setup attachments, and also we are recompiling and adding components, which is like, you know, always that's like one dangerous thing, adding new U properties and then recompiling. It almost never works. So I'm just gonna take a guess and say I need to actually restart. So let's do that. Welcome to Unreal.
I actually had the same problem, and the mesh is offsetted in the center of the scene.
Oh really?
Yeah.
Did you
So if
restart
you
it?
look, no, I did not restart. I just resetted the mesh because you can see it's in the middle of the scene.
Oh, maybe that's why. Yeah. Oh yeah, it is.
So-
Okay, that was it. Okay, yeah. So this is this is definitely has to do with us not setting up the attachment. So the mesh was not properly attached to the scene. So it probably wasn't even attached at all. It was probably just like its position was the world position. So that's probably why it ended up being there. So now that we have set up attachment, I can probably reset the position here. So I'll reset the default. And now it should snap to the scene roots. Yeah, so that was a good catch. So I was hoping something would go wrong, and it did, and I didn't. I wasn't ready for it. So yeah, always set up your attachments. So now we have a cylinder here attached to our actor. So that's cool. I'll make it a plane. Very sick. Of course, though, it's kind of annoying because if I make a new cool actor, like it's not gonna have any mesh by default. So I have to like go into every one of these cool actors and always like set the mesh to be something, which is obviously really bad. Like you want to have like some sort of default mesh. Like you want to have a mesh on the actor that's always set. And this is where it comes in with the whole like referencing assets, that's kind of an annoying thing. So there's two ways to solve, or I mean, there's many ways to solve this, but two main ways to solve this. One kind of bad way and one really good way, and I'm going to show you the bad way first, so that you know that it exists. But I am going to warn you that this is not how we do things generally. I've done this maybe once in my life. Or not in my life, but at Hazelight, I've done this maybe once. And it's to actually reference the asset directly in code. So that when we drag out the cool actor, like the code class, it will have the static mesh already set by default. So it will reference the assets by default. And the way we do this is that we make a special little magic struct in the constructor. So I'm going to make it static. And we're going to make a static struct called constructor helpers : f object finder. So an f object finder is a helper struct that will locate and load an asset for us in the constructor so that we can reference it. Excuse me. So it takes a temp. Excuse me. It will have a type name as a template to be which kind of asset it is. So if it's a static mesh or if it's an audio file or a texture or something, and we want to reference a static mesh. So I'm just going to type use static mesh in there. So we want to reference a use static mesh, and I'll call it default mesh. All right, and in the constructor. Hello. Okay, I'm not getting it autocomplete. Let's go to it. Here, in the constructor, it takes a path. So it takes a path. I said path and path. So it takes a path to the object to load. Pretty simple. It's not the direct path on in your on your computers, and it's not like d:/prog whatever. It's actually used as something called a URI, and a URI is a path that's defined by the Unreal Engine, so it's sort of relative to its own sort of file system. And the way that works is that we would go into engine content. Let's go into engine meshes maybe. Let's actually make it one of these cubes. I want to find these cubes look nice. So I'm gonna look at this static mesh here. I'm gonna click this little button here to browse it in the content browser. So here it is. And then if I hover over it, over the path, you can see there's the URI to that mesh. So it's /engine. So a URI in Unreal always starts with a slash. So it's /engine /VR editor /basic meshes. And that's the URI to this folder. All right, so we're gonna /engine /VR editor. So let's type that in. You can see why this is not really used that much. So we're good and good. /engine /VR editor /basic meshes. So that's the URI path to the folder, and then we want to give this a specific asset. And the way you do that is you type the asset name. So the asset is called SM_cube_02. You can of course choose any asset that you want, but I'm gonna do this one. So SM_cube_02. And then we have to reference which sub-object to select. So this is the asset, and then we have to select a sub-object from that asset. And we do that by typing .smcube02. So the sub-object, it only has one sub-object, which is the static mesh. So this is the package, and this is the object. Doesn't matter, don't worry about this. I'm just telling you, but you don't need to remember this. So this is the package, and then I'm referencing which sub-object from that package, and that's going to be the same name, so sm_cube_02. It's almost always the same. And this is going to be the full URI path to that static mesh. Semicolon. So now we have our nice f-object finder that will find and load this asset for us. So we're referencing it directly from code. So now we can check if default mesh dot is loaded. Whoops. Is, or maybe it's consequent. It's like succeeded. That's what it's called. So if it succeeded in finding and loading the mesh, then we want to do mesh set static mesh. Default mesh dot object. There we go. Whoops. So if we succeeded in loading this default mesh, then set the static mesh of the mesh component. So it's important to remember that this mesh is the component, and this object here is the actual mesh asset. So a component and an asset are two different things.
So the name of the constructor is default mesh, I'm assuming.
Sorry?
Is the name of the struct at the top default mesh?
Yes, that's the name of the variable.
Right, cool.
So here I'm declaring a variable, right? And the variable name is default mesh, and the type is this horrible thing. And this is just the constructor.
Nice, right.
Cool. So now if we recompile, it exploded. So we can check our cool actors, and okay, so there's nothing different here because we set the default static mesh here. We override it, overrid it, I guess it's the name, is the term. We overrid it in the inspector here. I'm actually going to remove these and place in another one. And voila, we have a cube. Amazing. So we've set the static mesh of our static mesh component directly from code. So we can just place out the code actor into the level, and it will have this asset already set and nicely. Very cool. So this is the direct from C++ reference method. I've used it maybe once. It is very clunky. You have to like look up the URI and then like hard code it in here. You don't have any control over when is this loaded. Is it loaded all the time? Like when it's kind of hard to realize that. So, you know, if you put a lot of assets in here, then it becomes a bit of a hard task to manage loading times and such like that. And also, you know, it's hard-coded, so if the artist decides to move this cube somewhere else, this is going to be used nothing. This is not going to reference it anymore, so it will break, and it's very hard to figure out why it's breaking, because it's in code and only you can change it. And only you can change it, so when the artists come in with a better cube, come in with SM Cube 3, and they're like, this is the final cube, they have to ask you to go in and change the mesh in code, which is also really annoying, and they're going to hate you for that. So that's why almost never this is how you do it. But I wanted to show you that this is a way. So, you know, sometimes this is appropriate. But most times, instead, what we do is that we do something that we've already done. I kind of did it kind of fast. Maybe I shouldn't have. But the way we do it is that we override the blueprint in... oh, it disappeared. Great. We override the blueprint... Sorry, we override the actor in blueprints. Tripping over my words a little bit. So what we do is that we override the class in blueprints. So I'm gonna search here in all classes. I'm gonna search for cool actor. So now we made a BP override or a BP inheritance for a cool actor class, and I call it BP underscore cool actor. There we go. So it has the cube. I'm gonna remove that actually for now. So I'm just gonna remove this. Just so we get the full experience. I'm gonna restart the editor as well, because you never know. You never know what's gonna happen.
That bool B can ever tick. Is that? Can you like set that somewhere? Like, can you reset it so it means that tick is being called always, right? I'm assuming.
Not always. It means that it will be considered to tick, but there's still other things you can do to disable tick.
Okay.
But if this is false, it will never even be considered to tick, so it won't be in like the main tick list.
But can you re-enable that somewhere?
I don't know if you can set. I don't think you can change this after the constructor, but you can do set actor tick enabled.
Okay. Right. Yeah.
So that's like the main way you do it in runtime to change if an actor should tick or not.
Okay. Cool. Thanks.
Yes. Okay, so now I'm gonna go in and override it for like the third time. So I'll do cool actor BP underscore cool actor. There we go. And then what we do is that in the BP version, we actually go in.
Emil, your screen is locked up.
Oh fuck. I'll reset it. There we go. It's better.
Yay!
Yay! Nice.
Hooray. All right. And then what we do in the blueprint version, that's where we set all of the assets references. So in here we go and set this to cube, SM cube 02. So we go in and override all of these asset references of all our components, and we set that in blueprints. And then what we tell all of the level designers is to say, don't spawn the base version. In fact, we might mark that as abstract to say like you can't spawn this even if you want to. Use the BP version. So then that's what they will drag in to the level.
But the code that's still run is gonna be the base class, right?
Yes.
Because so it still gets the C++ benefits of being super fast and stuff.
Exactly.
Okay, cool.
So we can almost see this like a property only blueprint. And actually that's sort of why that features in this feature here, where they don't even show the full blueprint editor, because they say like, oh, you only want to go in and change assets references. That's fine. Then you get like a matrix to do that. So this is considered like a blueprint that's not really used to code anything. It's just used to set asset references. But this is really good for a lot of things. First of all, if they want to go in and change the mesh, they can easily do that. You just go in and change it and save, and then they're done. If you want to add more meshes, let's say like, oh, we want to like add a mesh on top of this, like add a little cylinder, they can do that. They can just go in and add a cylinder, and it's fine. If they want to add Niagara effects, they want to add sound emitters, they want to add like all of this cool bells and whistles, there's a dedicated blueprint for doing that sort of things. So going and adding components becomes super easy. They don't have to go and ask a programmer to in and add like a Niagara effect for them. Like they don't want to do that. So 99 times out of 100, this is what we'll do when we need to reference assets when we make a BP version. Any questions on that? Cool.
So how do we get the reference? If you go into the blueprint version now, and then you add a cylinder like you did, how do we then reference that in the code?
You can't.
Okay.
If you need to reference it, then you have to declare it in code, like we did with our mesh, and then set it up in the BP if you need to reference it.
Right.
So this is for visual only stuff. If it's like, oh, the artists want to add like a little bell and whistle that doesn't really change gameplay at all, like it's not supposed to be referenced, it's supposed to be there, then it's fine to add it here. But if it's like, oh, I need to reference a cylinder to move it, then then you need to declare it in C++.
Right, but the first mesh you declared in code, and then it was there when you created the blueprint.
Yeah.
Okay. Yeah. Okay. Then I get it.
And I'm guessing like if you want to have like two different behaviors but the same kind of blueprint actor thing, can you make like two actors and just put them in to the same blueprint?
What do you mean?
Like I don't know, if you want to make like a big object with multiple different C++ objects scripts, can you kind of compile them into a blueprint of its own, like multiple actors?
You can have child actors, but I don't trust them.
Okay.
We've used child actors, they didn't work, it was horrible, we cried. So no, the way I would do that is to just put them in the scene and then have some sort of owner actor that has references to those actors, and that's sort of the controller, but you have to place them out in a scene. We've been talking about in Hazelight doing some sort of prefab thing where, you know, you can do that, what you're saying, that it looks like a prefab is only like a collection of actors essentially, and that you spawn as one, but it's not natively supported in any way, unfortunately. So that's one downside to this actor thing, that if you split things up too much, then it becomes kind of, you know, annoying that you have to place them out one by one and stuff. But it's not a super big deal.
All right, cool.
Let's take a 5-minute break, just to grab some water and stuff, and let's continue at 14. Hello.
Hello.
How was your
Hello.
break?
Good.
Quite good.
Nice.
Good.
It's good to hear. Did you do
I
anything
just
fun?
had time to start programming on the old SDL project.
You're like fucking like hot swapping into SDL, like fixing bugs.
Yeah,
That's crazy.
definitely. It's
Wow.
gonna remake the whole controller system
Oh, sick.
in a 5-minute break.
It's like extreme programming.
Jesus Christ.
So what do you do when the compiling here Unreal takes too long? Do you just restart the project?
Yeah. I mean, if it got stuck like it did before, I would just restart. Probably something went wrong. Again, they claim they have fixed it, but I don't know. They have this like enable live coding. I actually don't know what that means, but I don't know. Experimental seems
Push it.
scary. I don't want to. I want to click it.
Push it.
All right. So so cool. Let's make our dude do something. Because right now it's kind of boring. It's just hanging there. Doesn't have a collision actually. That's kind of weird. Oh, okay. The player camera doesn't have collision. Oh yeah, I'm simulating. That's why. There we go. Now, there we go. Now collision. All right. So it's not doing much. Let's make it actually do something fun. So let's make it move. I would say. I think that's a pretty fun thing to do. So I'm just gonna go into the tick here. So the tick is called every frame. So that's a perfect time to make something move a little bit. So I'm just gonna do add actor world offset. So add actor world offset will move the actor by some delta distance. So we have here delta location. So I'll say, okay, let's make it move in the x direction. So let's do I don't know 500, I guess. Something like that. So it should move to this way. So it should like be like and hit the wall. Let's compile. And play. Hello? You're supposed to be moving. You're making me look bad. Is the tick even running? Let's break. Nope. Nope, it's not running. Okay, let's restart. Fuck. You see why I don't trust recompile? Sometimes it's like it just refuses. Maybe I did something wrong, I don't know.
Was it back in 2015 you said to your students that they shouldn't use recompile and it's still trash?
Yeah, they was like, no, we fixed it, it's great. And it's like, yeah, well, look at this. Seems fine.
Yikes.
Yeah, big joke. Somebody's gonna drag another cool actor in here. And now if I hit play... Okay, so that's a little bit faster than I thought it was gonna go. You can see here, okay, it's moving fast. It's going into the stratosphere. Can anyone tell me why is it moving so fast?
You're
Like
not-
500 units
you're
is
not
not that
taking
much.
delta time into account.
Yes, exactly. I'm not taking delta time into account. So I'm
So that's-
adding 500 units per frame. So of course we wanted to move maybe 500 units per second instead of 500 units per frame. So of course we wanna multiply this by delta time. And this is something called frame rate independence. When you take units such as per second, you know, per minute or something like that, that's called frame rate independence. Because what happens if we have a fast frame rate, it's going very fast because there's more frames per second for it to actually move 500 units forward. While if we're on a slower PC, like maybe we're like 20 frames per second, then it's actually gonna move slower because there's just less frames in 1 second for it to move. But with delta time, it doesn't matter. It will move as fast no matter what your frame rate is. So that's called frame rate independence. Very important. We have like rejected programmers because they didn't know what delta time did. So I'm just gonna like really hammer home. Delta time is important. if you don't know how to use it, then that's bad.
Isn't that why tons of the Japanese games that get ported to PC are always so super funky in the beginning? Because everything is basically frame rate locked because they're all console games. Because I remember like Vanquish being like twice as hard because now it's in 60 frames per second rather than 30.
Really?
Yep,
Oh.
there was a big thing like, oh, it's too hard because literally everyone's doing twice the damage because you have twice the frame rate.
Wow.
And I feel like that's not the first time. I feel like Dark Souls had something else that was like frame dependent as well. It just seems like the Japanese don't really want to bother with the PC and variable frame rates.
Yeah, maybe that's true. I don't know, but yeah, it is. I mean, sometimes in our game in It Takes Two, there's frame rate dependent stuff here and there. Like it's impossible to go like 100% independence, but yeah, you should definitely try your best so you don't, so your PC players don't do max damage. So now when I move, it is actually moving at like a stable stable speed. So what the fuck is that? What is this? What is this? Wait, what are you doing? What is that there? Oh, it's another.
Is that like an override or?
Oh, it's another cool actor. Oh, okay, it's a cool actor. I just didn't. It's like from way behind when it's okay. So let's just remove this one.
How big is the unit compared to like in Unity? It's like 1 meters per unit, right? In Unreal, how big is it?
Generally, it's 1 meter. It's 100 units. So 1 unit is 1 centimeter.
Okay.
So
right.
500 units is not that much. It's roughly 5 meters per second. So there it goes. So that's cool. It's pretty neat, I would say. So let's say we want to be able to set the speed of this thing. Right now we have hard-coded it, but let's say we want to be able to set some sort of, how fast it's actually going. Of course, we could go into code and just change it here, but what if we want to have 2 boxes, and we want them to both go at different speeds? I know we're asking a lot here, but it's cool. Unreal is a very good engine, so we should be able to handle this. So the way I would do this is probably make some sort of property so that we can change. So I would make maybe a floating point that's a speed, and maybe set that to 500 by default. And then, and then I will change out this 500 to instead hardcode 500. I will instead hardcode speed in there. So that's cool. So now if we compile, this should work. There we go. So it works, and if I play, then yeah, they're both going at the same speed, so that's nothing changed there. But of course, it's not here. Like we can't find it here. If I search for speed, I find nothing. And that's because, as with the components, we have to actually expose this property to the engine, to the editor. So same as with the components, we're gonna declare this as a U property to expose it to the engine. Now if I compile, then still nothing. And as with the component, we have to make sure it's visible to the user, to the editor, to the inspector here. So we have to also put visible anywhere. Now if I compile. Let me know if I'm going too slow, by the way. I'm taking it like one baby step at a time. Maybe I'll do like a poll at the end or something.
Can the variables be private or public? Does that matter?
They can be private. I don't know. I actually don't know what that would change. First of all, so here we can see. Okay, so it's visible, but it's constant. We can't change it. All right. So that's the thing with visible. It means that you can see it, but you can't change it. All right, and that's where another meta tag comes in, called edit. So here's edit, and it has the same things. And edit anywhere, edit defaults only, and edit fixed size, edit inline. I don't even know what this means. Edit instance only. And this is that we can't only you see it, we can also edit it because we can set the variable to something. And I'll take your private question soon, by the way. So it's coming out. It's coming up. So instead of visible anywhere, I'm gonna set it as edit anywhere. So I will compile. we go. And now you can see the speed variable here is actually something that I can change. I can drag it, or I can type in a value. So if I type in 250 for this boy, and this for this other boy, I'll keep it at 500. Now if I play, this one is going twice as fast as this guy. So cool. So now we made a property that we can actually edit in the inspector here. And for private, let's actually try it, because I've never tried. So let's make it private and see what happens. I don't usually use public and private. I'm usually more of a public everything kind of guy. I'm a Republican. Get it? Okay, anyways. Please laugh. Okay, so so it didn't change anything.
Please laugh.
But I'm guessing. I'm guessing
Same.
if I restart the engine, I think this is a sort of a hot compile quirk. Sometimes it's a little bit slow to update stuff like public and private changes, edit and visible changes. So I think if I restart. Now if I search for speed. Oh, whoops, wrong one. There. Speed. Oh, it's still visible. Okay, so I guess it doesn't matter. I guess you can. Public and private does not take into account that sort of thing.
Cool.
Great. So I want to touch on one more thing on your properties, and that is these other edits, right? So we had edit anywhere, then we had the edit defaults only, and then we had the edit instance only. And sometimes these are useful to have. For example, if we want to say like, okay, we want to be able to change the speed, but we don't want to be able to change the speed in the actual editor. We want to set a speed in the blueprint and then have that be set. Be like, okay, we can make one blueprint override that goes at one speed and then another blueprint override to go at another speed. We can change those, but we don't want to be able to touch those in the editor. That's when we want to make it edit defaults only. So I'll do edit defaults only. Let's see what happens. There we go. Now, if I search for speed, I'm not finding anything. So it's been removed here, because this is an instance. This is an instanced actor. And since I made it edit defaults only, the instance cannot touch the those variables. But if I go into our BP here, BP cool actor, then here is the speed, and I can set this to something. So I can set this to be 1500, for example, because this is the defaults menu. You can see the class defaults. So this is the default values of this class. So edit default only means I can go into the blueprint and change them, but they cannot be changed in the actual editor itself. Or in the level, I should say. Conversely, sometimes you want to have a variable that sort of, it only has to do with the level. Like, for example, if I want, if I have a group of these dudes and I want to define like, oh, these guys, they are in a squad, so they should have like references to each other or something. I want to reference something in the level, which is sometimes what you want to do. Then you might want to have a variable. Let's just do that actually. Let's make a variable that's like, it's going to be a cool actor pointer. So I'm going to a cool actor pointer. I'll do like friend. I'm going to define a friend. And I say like, okay, I want to only to be able to define a pointer to a friend in the instance window, because that's where only where it makes sense. Like, I can't set a friend in the default window because there's like, it's not in a level. There's no other actors that I can reference. It's only in the level where there are other actors around that I can actually reference. So that makes sense to make it, okay, this is an instance only property. So then I'll do edit instance only. Compile. Like this, like someone's AC in the background. It's like the perfect like background noise while I'm compiling. It's like.
Oh, like, sorry, that's probably
like
me.
No, it's fine. It's fine. It's sort of that's funny. All right, so now if we go into the cool actor, we should be able to find a friend. There it is, friend property. So if I drop the dot down here, I can select one other actor that I can set this property to, or I'm gonna use the little drop mark here to pick an actor from the scene. So I can set these properties to be pointers to other actors in the scene. Very nice. However, if I go into defaults, so if I go into the actual blueprint, then that property is not visible here because I made it edit instance only. Because it only makes sense to edit it in an instance. Of course, you could just make all the variables edit anywhere. Like it's not like nothing's gonna break by making it edit anywhere. It's just like, oh, you get a little bit of a cleaner details window, which could be nice. So that's uProperty and that's uProperty specifiers. So I think that's good to know. It's okay if you don't remember them. I sure as hell don't. So I open this up very frequently just to look them up. So nothing you need to commit to memory, but it's good to know like, oh, there is a property that does like edit instance only. That's good to remember. And then you slowly learn the other ones, what they do. Can do cool things. Great. Okay, so now we have that. So now let's get oops. Sublime. Let's get the speed back in. So I'll just do edit anywhere. Vim, what's happening? Okay, so sorry.
Colin had a question in the chat, by the way.
Oh.
About if we can have references to other actors, or do we need the pointer?
Can you explain the difference?
I mean, I think he's talking about the ampersand versus the pointer, or Colin?
You cannot do no, you cannot do ampersands. Okay. Because that doesn't really make much sense. Then you can only set it once, and it can never be null pointer. It would have to be like set in the constructor, which like you can't pass anything into the constructor. So as far as I know, no, you cannot do any references. But I mean, I would think I think it would be a bit weird to have references, but yeah, you can just check it if it's like you can do like if it's null pointer, then crash. I guess you can do that. But yeah. So I'm gonna get the speed back in here, and I edit anywhere, and then I'll compile. Okay. So what if I wanted to stop? Okay. Maybe get rid of these guys. Fucking play over here. There we go. You're in the way of the science. Okay, so if I want these guys to hit the wall and like stop, how do I do that? I'm trying to find the speed. Okay, so this one going 1.5, and I'll set this guy to go like 500. I want these guys to hit the wall and stop, because right now they just like fucking barrel on through. They don't give a shit. So the way we do this in Unreal, or I mean, there's a few different ways. There's not one way, but one easy way to do this is that when we add the offset, by default, it will just put the actor there, like when we add the offset. And if it has simulate physics, it might try to, like, after we put it in the wall, to like depenetrate to get out of the wall. But since we're not simulating physics on these guys, it would just be in the wall, right? It has collision, but it will just like be inside of the wall. And then we're gonna add again, and it's gonna be put a little bit further into the wall, and so on until it's out the other side. But what we can do is something called a sweep. So what a sweep does is, instead of just putting the actor there, it will actually trace for us to the target location. So it will do a shape trace. And if it hits something, it will stop there. Okay, so it will like sweep, and then, oh, I hit something and stop. So it won't go into the wall, it will just go up to the wall and stop. And that's called a sweep. It's very useful when you're doing soft like character movement, or really anything that should move and interact with its environment. It's very good to do sweeps.
So is that internally like a ray cast or like a box cast?
It's a shape cast. So these collision, or the collision of this actor is defined by these components, right?
Mm-hmm.
And in our case, it's static meshes. which means it will have a static mesh shape. So it will actually ray trace with the shape of the of this mesh, whatever that happens to be, if it's a cube or if it's like a complex mesh or what have you. But if we had like a sphere collider or something, then it would do a sphere trace. Or if we had a box collider, it will do a box trace or a capsule trace or whatever. But in our case, it will do like a mesh trace with this shape. Cool. Cylinder might do a cylinder trace. So let's do that, and it's quite easy. In the add actor world offsets, we just go in here and check the parameters, and here's bool b sweep. So we can set that to true. So now instead of just putting the actor a certain amount away, it will actually sweep there and see if we can put the actor there. And let's play. So that worked great. Fantastic. I think it was because I didn't actually have a hit result. Yes, block all dynamic. I think it was because I didn't have a hit result. So that's actually... Oh, I didn't compile. I'm stupid. Yeah, I'm not in AngelScript. Fuck. We have something in Hazelight called AngelScript, which is like a bridge between Blueprint and code. And there, if you save, it just compiles automatically. So I was just used to that. So let's see what happens now. Okay, that worked great. So let's try, because the sweep, if we hit the next one, we can see here out sweep hit results. So we can actually get the result of the sweep out as a hit. And a hit is has info about like what component did we hit, what was the normal, what was the penetration depth and stuff like that. So we get the result of the collision. So we can just I think I actually know why this didn't work. But let's try this. So I'm just gonna set the hits. Might be that. I don't know. I never remember. So I'm gonna pass the pointer to this hit result into the sweep. And let's see, maybe it does like an if check or something. I didn't compile. And let's play. Nope. Okay, so this is Unreal stuff. So the reason this doesn't work, usually in at Hazelight we don't really use the Unreal sweep like this. We don't use like move with sweep set to true. We do the sweep ourselves. We actually, you know, pre-moving, we take the shape we want to sweep with and we sweep manually to get the hit, and then we move the actor there. The reason for this is that Unreal is very finicky when it comes to like, okay, what's actually the collision of the actor, right? Because we're moving the actor, and the actor itself doesn't have any collision to it. Like the actor is just a thing with components in it. It doesn't have any collision data. So what it does, I'm assuming here at least, is that it takes the root component to be like, okay, this is the collision of the actor. It taking the root component to denote like you're representing the actor as far as collision goes. And that's what it's using to do the sweep. So the problem here that our root component is the scene component. And as I said before, a scene component is the most basic transform you can have. It has a transform, it has a rendering, but it has nothing else. Like there's no collision here. A scene component has no collision data. So what's happening is that it's when it's sweeping, it's saying like, okay, your root component doesn't have any collision, so you don't have any collision as an actor, so you just go through the wall. So it doesn't detect any hit. I hope. My God, if this is not correct, then dear golly. So I'm actually gonna do like this. I'm just gonna set the root component to be the mesh instead. So I'm just gonna do root component is equal to mesh. And the scene, I'll just get rid of it. I don't need you anymore. So, and then we'll remove this setup attachment because we don't need that anymore. There we go. So now I'm actually setting the static mesh component to be the root component of the actor. And what happens then is that when you query the actor for collision during a sweep, it would look at the root component, see it's a static mesh component, and say, okay, you have actually collision tied to you. You have, you know, the static mesh collision. And it will use that collision to then do the sweeping. So now, if we compile and if it works, This is the thing with Unreal. I remember when I did this course the first time, I wasn't as like aware of the Unreal quirks as I am now. So it was like, and now we're gonna hit the wall, and then it's like it just went through, and I was like, let's take a break. Actually, I was like fucking frantically trying to figure out which checkbox I didn't like fully click and stuff. Okay, so now let's play and see what happens. Ah, thank God. Okay, so it hit the wall and it stopped. Applause, please. Please, applause. Thank you. Thank you. Yeah, I'm a programmer, by the way. So, anyways, so now when it's sweeping, it's taking the collision of the box and doing a sweep test to see if it's hitting something. And it's hitting this wall, so that's why it's saying, okay, you can't go through. So it stops at the wall. So that's cool. So what can we do with this? One thing we can do that's quite easy is that we can just take the hit results. So remember, I put the hit in as a pointer. So this hit result is gonna contain the information of the hit. The first most basic thing we can check is, did we have a hit? Did we hit something? And by doing that, and to do that, we do hit.b blocking hit. For some reason, they've decided that every bool is always preceded by a little b, like a tiny b. Only the bool, nothing else has any sort of prefix. Only the bool. I have no idea why. Ask Sweeney. That's the way to do it. So yeah, so this will be true if we actually are hitting something. So let's say when we hit something, we want to print like ouch or something. So let's just do UE log temp, log, and then we'll type owie, 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 ouchie, boo boo. There we go. And let's see what happens. Let's compile. So we're going to, yeah, they're having lots of boo-boos. So they're hurting, and then you can see, like, if I select something, it's like, pew! It like runs off because they're printing every frame, since they're trying to sweep every frame. So maybe let's do, so if it hits something, it's like, ow, then it changes direction and then it bounces back. So it will maybe go like back and forth like this. That's like rapidly approaching like a game. So let's do that. So I will do, if it has a blocking hit, then I'll use reverse speed. So I'll set speed to be minus speed. Compile. Wow. Wow. Oh, wow. Look at that. Wow. Oh, God.
Okay, have the speed reflect off the wall?
Yeah, that's a good question, actually. Yeah, so... Okay, so that's a really good question, because actually what I wanted to do next. So, right now, it only goes in the X direction, like world direction. So if I rotate this, you know, it's still gonna go in the X direction like this. But what if I wanted to go forward? I want it to be like, okay, you should go in your forwards direction. Yeah. I got stuck. Okay, so yeah, so how do we do that? Well, I would probably... Yeah, I think the safest way of doing this is gonna be, I'm gonna make a velocity, a velocity vector here. So I'm gonna set the speed, but then I'm gonna have a separate variable that actually tracks the actual velocity here. So that's gonna be our world, like how fast we're going in the world. And then the speed is gonna be a setup for us to say how fast you're gonna go. But then later on this will track how fast we're actually going. So what I'll do in begin play, I'm gonna set velocity to be the speed in the actor's forward direction. So I'll say like, okay, we can do get actor forward vector. So that's gonna, God, excuse me. So that's gonna return the forward vector of the actor, and that's the x-axis. So So that's the red arrow in the gizmo here. If I put this into local mode, this red actor is going to be the forward vector. So I take that and I times that by speed. So now I'm setting the velocity to be the forward vector times the speed. Cool. So now our velocity will be how fast we're moving and in which direction. So instead of adding just the f vector with hard-coded speed and x-axis, I'm instead going to change this to be velocity. Like so. So now we're going to move in velocity times delta time instead. So let's see what happens. So now hopefully I should be like aiming to hit these guys. Let's see what happens. Okay, so that worked great. Because I didn't recompile, because I'm a dummy. Okay, there we go. So now they stop because we're reversing speed, right? Because when we hit something, we're doing like our speed equals minus speed. But however, we're not using speed anymore. We're only using speed in begin play. We're not using it in tick anymore. So even if we change speed, like nothing's gonna change. So instead what I'm gonna do is I'm gonna do velocity is equal to minus velocity. So now we're reversing the velocity instead. And see how that, whoops. Let's see how that pans out. I like this ignore junk here, by the way. That's what I put on my Tinder profile. So let's play and see what happens.
Those toxic people out of your life.
Ignore. Okay, that's not what I was thinking, but yeah, sure. Then it goes back. And now it's actually, yeah, they're like hitting each other as well. So it's like a cool game of Pong. So that's cool. So how would we make it bounce? Like if I want this guy, if I'm pointing him towards the wall like this at an angle, how would we mathematically make him bounce off the wall and like continue off this way?
Dot products.
Dot products?
Mm-hmm.
How?
I don't know if I remember this now.
By using the normal of the wall.
Yes.
The normal of the normal.
Oh, the normal of the wall.
Yeah.
We need to fetch the normal of the wall. Then is it the dot product of the normal of the wall times the current velocity? Can't remember.
It's close. It's I mean the actual I was gonna say you reflect it. That was the answer I was looking for. But if we wanna get like actually mathematical, then the way you do that is if we have a wall, we take the normal of the wall, like so. It's normal. And then we have the velocity coming in. What we do is that we get the part of the velocity that's aligned with the wall. And the way we do that, if we have, V and N. This is not a mathematics course, but I think it's so important to actually have a grasp of linear algebra. Like there's nothing more important that you can learn than linear algebra. So that's why it's like, if there's an opportunity to talk about linear algebra, I want to do it because it's so incredibly important. So to get the velocity that's actually aligned with the wall, like this here, right? This is the part of the velocity that's aligned with the normal of the wall. To get this vector, we do V times, not I'll do a dot. V, I'll do cross actually. V times V dot N. So that's the formula to get this vector here that's aligned with the wall. So it's essentially how much of the velocity is like going into the wall. And then what we want to do, if we do V minus this, if we take away the part that's facing into the wall, what will happen is we'll end up with, if this is V here, and then this part is something like that. If we take V minus this part here, then we'll get the velocity along the wall. So this velocity here will actually have the same angle as the wall itself, like this. Because we've taken away all the velocity was pointing into the wall. So what we're left with is just along the wall like this. But then here's the tricky part, or here's the cool part. If we do that shit again, yeah, fucking I'll do it again. If we take this and we minus it one more time, like this, then what's happened is that we've flipped the velocity that was going into the wall. So instead of this being pointing towards the wall, it was actually gonna point away from the wall instead.
Ah, that actually makes a lot of sense.
Yeah. And then what's gonna happen is that we're gonna have the same angle. Like this angle is gonna be exactly the same. And that's the definition of a reflection. The angle of incidence is equal to the angle of reflection. And since these two triangles are equal, like the base and the side is equal, this angle will also be exactly equal. So that's why if we do v minus this vector times 2, then we'll get the reflection vector going off like this.
Okay.
Very cool. Or we can use reflect, the reflection function. But now you know, there's the mathematics behind it. It's very cool. Never be scared of doing linear algebra. It's so fucking useful. I cannot begin to explain. Me teaching designers linear algebra has made them be able to make so much cooler stuff because it's so
I'll fucking
important.
say, especially when you have a grasp of matrices as well.
Matrices, yeah, that's when it comes to transforms and stuff. That's when it's like fucking god mode. It's like I can make it. Like it's like just leave me alone for a minute and I'll make magic. So yeah, transforms also very important to know.
You can assume my ultimate form.
So what we'll do is that we'll say, okay, velocity, I'm gonna reflect this along the normal of the hit. So there's a very neat function called fmath reflects get reflection vector. And it takes the direction, which I don't know why you call it direction. It should be calling it should be called a vector or something. But it takes the direction and then reflects it along a surface normal. So I'll use direction is going to be our velocity. So that's going to be the vector to reflect. And then a surface normal is hit.normal. All right, so this f-hit result has the normal of the hit inside of it. So if it is a blocking hit, then this normal will be set to what the impact normal was. So now we're setting velocity to be the reflection vector, of velocity and over. It's weird when it's like you haven't talked for like a week to anyone, and then it's all of a sudden I'm supposed to hold a course. It's like I can't talk. You don't understand. Okay, so anyways.
Corona be like.
Exactly. It's like I don't know how to socialize. I don't fucking know. Okay, so let's compile this and see what happens. Okay, and let's play. It's like Pong.
It's like one of those, DVD.
Oh yeah, exactly. Like, will it hit the corner? Oh, no. No.
Hey,
Okay. Okay. Anyways.
So close.
So yeah, that's one way to do collisions.
Oh, it collided off the other actor.
Yeah. That's sick. Oh! Yeah, I'm a fucking game developer, dude. Okay, so anyways. So that's that. And let's maybe make it... Alright, let's make it have gravity as well. Let's make it like bounce on the ground. That's cool. So I'm actually gonna just add some gravity to this. So let's do velocity minus equals, and then apply some hard-coded gravity. Let's do like 900 or something. Whoops. So I'm just minusing the velocity by 900 every per second. So this will be our gravity.
Wait, so Z is up and down?
Yes, Z is up and down. I should have said that. Z is up and down. I know you're from Unity where Y is up, but
yeah.
Here we're civilized and use setup.
Well.
So now I didn't compile. There we go. So now let's go. So now they hop along the ground nicely. Oh yeah, look at him! Oh my god, he made it! You fucking made it, you son of a bitch! You escaped this hell on earth. Yeah, so that's cool. So yeah, I wonder if there's one more thing we can maybe do before calling it a day. Tomorrow we're gonna look at doing player, because right now we're just a debug camera, right? But I want to have like a player moving around, but I'm thinking it's a little bit too late to do that. Maybe let's do...
Just a question about sweep. Is there like a performance cost to it? Or how expensive would that cost be?
Oh my god, I fucking knocked them over. It's... I mean, it's... I mean, of course it has a performance cost, like it's a trace. So it's gonna cost something, but... it's... I mean, you can maybe do like 50 a frame on Xbox or something, I would say.
Okay.
I think on Xbox we had something like maybe at most 20 per frame actually, I think. But it depends on like how much other stuff is going on. But it's not cheap, but it's not like, oh, you can do one and then you're fucked. It's like, oh, you can do a couple, but
yeah, so generally like for the player and maybe something else.
Yeah, for sure. The player is gonna eat up like half of those sweeps, and then you might have like a gun or something that's ray tracing, or an enemy that's ray tracing to check your visibility or something. But yeah, I will keep it around like 40 is like probably the most you would ever need to do on PC. Cool. That is. But yeah, if you're shipping an Xbox, then you're fucked. You can't do anything. Sweet. Let's actually do overlaps as well. Actually, so let's say like if these guys go into some sort of death area, some death ball, then we want to say like, oh, they should be destroyed. They should be annihilated. So I'm gonna make a new class. I'm actually gonna make this the old school way, the way I like to do it. So I'm actually gonna make it fucking manually. I'm gonna go into, just to show you there, so you can do this as well. So if you go into, what was it called? Oh fuck. Oh, excuse me, Jesus. Okay, so if I go into source and I go in here and I'll just make a death ball, baby. So let's make a header and a C++ file here.
Wait, why are you making the files manually? Is it just because it's gonna be like empty?
Yeah, it's empty, and that's just how I like to do it. And I don't like the generated code that they give from when you do it from here. I like to start from scratch, but it's not one you can do it how many ways you want. One annoying thing, of course, is that when I made it like this, it's not gonna show up here because this is using filtered mode, so it doesn't show all the files. It's only showing the filters, which is generated by Unreal. So what we have to do is that we have to regenerate the project files for this. So to do that, because I wanted to detect these two files that I've added here. So what I'll do, it will still compile. I'll say that. Like if I if I notepad this, if I like go into Deathball and like notepad that, let's get Sublime, whatever. I'll do like, and then try to compile it. Actually, it's a header. It might actually, yeah. Okay, let's do the C++ file instead. Blah 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 blah, like that. Then maybe now. Yeah, there we go. So it still compiles it, like that's fine, but it won't show up in Visual Studio, which is another reason that I don't like to use Visual Studio, because you have to do this sort of like remake the project files. I like in Sublime, I can just make a new file and it's just there and it works, and I don't have to worry about it. But either way, to make Visual Studio catch up, I will regenerate the project files, and the way I do that is by right-clicking the U project, and then just do generate Visual Studio project files in here, like that. And that's gonna remake the SLN file. It's gonna actually not the SLN file. It will remake the VCX project files, the ones that has the file filters and stuff like that in it. So now it's been regenerated, and if I go into Visual Studio, it's gonna say like, oh, it's been modified, and I have to reload it. And unfortunately, that means I have to stop debugging, so I will do that as well. There we go. So now we have opened up a new solution, a new project, and here are the Deathball and Deathball files in here. So now we can start coding. So I will make a pragma once, don't forget that, and I'll make a Deathball. And also, I forgot to mention this. Actors always start with A. That's the naming convention. A stands for actor. So if I'm making an actor, it's called A and then whatever the actor name is. And same thing, you know, when I'm inheriting from actor, it's called a actor. So A for actor, and then actor stands for actor. Similarly, U objects start with U. And that might seem weird because actor is inherited from U objects, and actor is the only exception. Actor inherits from U object, but it changes the naming convention to A instead. But everything else inherits from U objects, which includes components, assets, some other things. All of those things start with U. So that's why when I typed in static mesh component, for example, and static mesh, those were called U static mesh component because it's a U object. So they don't have any sort of special naming convention. It starts with U. Additionally, the last one is F. And that's for everything else. So everything from classes to structs to... I think that's it, actually. I think those are the only two things. So classes and structs that are not U objects are called F something. The F stands for float, which apparently before was a thing. And Sweeney was like, it's great, let's keep it. So now it's there. So that's why F hit results. If I go into that, that's just a struct. Sure, it's a U struct, but that doesn't matter. It's still just a struct. That's why it's called F hit results. So that's the naming convention of Unreal, and it's enforced. So you cannot compile an actor that doesn't start with A, which is great. So it's good to know. So I'm going to make a death ball. I'm going to include actor. So I'll just include gameplay framework. Game framework. Actor. There we go. And then remember we have to include the death ball generated.h. Again, it will remind you of this, so the error messages are actually kind of helpful. So it will remind you if you forgot to include the generated.h. Then we'll declare this as a U class, like so. Then we'll put the generated body in there. Sweet. So I will make the death ball just be a sphere collider. All right. So I don't want it to be a sphere mesh. I want it to just be a collider that can overlap with things. So I'm gonna make a U sphere component. So a U sphere component is just a sphere overlap component. We will see it in the engine later. It might make more sense there. So I'm gonna call that sphere, and I'll make that a U property visible anywhere. Great. And then I'll also make a death ball here, constructor. Since we have to set this sphere up, I have to make sure I make a constructor for it. So I will create the implementation for the death ball constructor. I will include deathball.h, and then we will just add it as a default. Create default sub-object. U sphere component. Called sphere. Then I'll set that as the root component, like so. Cool. Let's try and compile, see what happens. I'm getting angry red lines, but you can never really trust those. That looks pretty good to me. So we're getting these garbage errors because, you know, C++, but here's one that's actually no, wait, no. Oh, there we go. Okay. Here, missing type specifier int assumed. Okay, this doesn't mean anything, but what it means actually is that it doesn't know what a uSphere component is. So I'm just gonna forward declare it here. It's always a good component. There we go. It's always a good habit to forward declare when you can. There we go. All right, and here it's saying cannot convert from uSphere component to uSync component, which is bullshit, but it's probably because we haven't included it. So we have forward declared it, but we haven't defined it. So I'm actually gonna include it here. It's in components, sphere components. At least I'm guessing that's why I'm getting that error. Yes, there we go. So it's like, just because I've worked with this engine so much, I can like interpret these errors. But let me know, like, this is so hard to figure out. Like, you just have to you just have to work with it a lot to figure out like what's going wrong, why is it going wrong, and so on. So it's a journey. But let's play and see what happens. I have to send a quick. So you could send a quick text. Okay. So hopefully now we should have a new actor called a Death Ball that we should be able to place out in the world. Go into our cool map. Should probably make this the default. What? Setup attachment cannot be used once a component has already had attached to use to connect it to a parent. Why are you telling me this? Okay, so let's see what's happening here. It's loading. Where is it loading? Oh. Oh, this stack is horrible. Can I get like the mesh? Okay, what's your owner? This is not what I was hoping would happen. Check its Oh. Don't crash on me, Wishidio. Don't crash on me. Okay. Owner private cool actor. Okay, so we have fucked up something because it's saying on the cool actor, which worked fine before, for some reason we're calling like setup attachment twice or something. So let's see what's happening in the cool actor then. Fucked something up. Create default subjected. Looks fine. I'm wondering it's because we saved the actor. I think it's because we saved the actor in a weird way. So we saved the actor when we like hot compiled and we changed around the attachment in code and hot compile and spawn actors. I think that's what we're getting this morning. So I'm just gonna ignore it for now and just replace those actors. Again, hot compiling. I'm suspecting that's why, because I couldn't see anything wrong at least. Okay, anyways. So I'll take a death ball and I place it out in the world. As we can see here, we have a little sphere component here. You can see it's like a little line drawn sphere. So this is what's called a sphere component. It's just a sphere collision, and it can do overlaps with other actors and other components. It can also be used as just a hard collider, like a blocking collider. We might talk about that later, but as a default, it's overlap only. So, you know, if I set this guy to move towards this component, nothing will happen. It will just move right on through. So it's not blocking this. Oh, bye-bye. It's not blocking our actor at all. I don't want to live anymore. Okay, so, but if I take this sphere and I set it to be, instead of here overlap all dynamic, this is the collision presets in collisions. I can put it here as block all, for example, and then instead it will actually bounce against the sphere because now it's a blocking sphere, it's not an overlap sphere. Not super important, it's like good to know. We will look way more at collision later, so, you know, don't worry like you need to remember this. Just wanted to show you real quick. And here I was flipping with the radius of the sphere, right? So you can either scale it, you know, by scaling the actor in this case, is the root component. But you can also go into a sphere component and change its radius independently. So let's set a radius to something like 200 or something. Let's actually do that in code, so we have that by default. So I'm just gonna in the death ball. I'm just gonna set the sphere, set sphere radius. I'm gonna set it to 500. But how do we detect if it's overlapping? Like, how can I want to see, like, okay, when this guy goes into this sphere, I want it to die. I want to destroy it horribly with, like, an explosion or something. How can I do that? Because right now nothing happens, right? It's like, okay, it's overlapping, but I mean, I don't have any code running when it is overlapping. So we need to sort of hook that up somehow. And the way we do that in this case is that if we look at the sphere, it will have an on component begin overlap. So this is a delegate, or I guess you would call it an event if you're used to Unity. Like this would be an event. So what that means is that we can subscribe to it and we can remove ourselves from it. So multiple things can be subscribed to the same event to get like data for when it's beginning overlap with something, as opposed to a delegate, which is just a pointer to one function. So that's the difference between a delegate and an event. So we can subscribe to this. We can like add a function to be called when this is fired. So the way you do that is horrible. What you do is that, okay, so this looks great, right? It's like add, which has like some sort of F-script delegate struct or something. I don't know what that is. And then there's like these internals here, and you know, this looks scary. Like if you see a function that begins with underscore underscore, that means like that's fucking dangerous. Don't look at that too hard. So what you do is that you just do add dynamic, which is a macro. So here's a macro. Yeah, I told you, okay, so hold on. Don't laugh. So it's a macro that you call, and then you pump in a user object and a function name. And it's a function name, but it's actually a function like a pointer, but it's just being converted to a name. And this will call the internal add dynamic on the delegate. So delegates are fucking horrible in Unreal. I hate them so much, but you know, it is what it is. So what you do is you call add dynamic, and then you have the user objects, and that's what the object to call is. So that's gonna be this. This is gonna be, we want to call this object here. And then the func name, and that's just the regular funker pointer, the function pointer, and that's gonna be a def ball. Oh, we have to create a function actually, so let's just create like a void handle overlap. Whoops. There we go. And if you didn't know, this is how you do a pointer to a member function in C++. So you do the class name colon function, and then always the @ in the beginning. Cool. So now we are adding our handle overlap as a callback for this onComponent begin overlap event. Hopefully that makes sense, even though the syntax is actually horrible. So let's compile.
I guess a quick question while it's compiling. How did you learn all of this stuff? Like, is there a documentation, or do you just learn from colleagues?
There is documentation. I mean, I wouldn't trust it. I mean, the documentation is okay. Like, I mean, you could probably do like how to bind the two delegates UE4, and there's like bind delegate with one parameter, usually here. So yeah, you can find some stuff here. Like, it's sometimes good, sometimes not. But the easiest way to learn these things is to just search the code. So it's like, okay, in this case I would probably do like on component begin overlap dot. I would search for that and see like what I get, and then I would see like people are doing this add dynamic stuff, and I'm like, okay, that's how you do it. That's usually how I figure stuff out. Sometimes I go into I use Alt G and see like, okay, what's here, and then I Alt G on the signature.
But so the macro itself is defined in the class, like it should, right?
The macro is defined here in delegate.h. So, I mean, the macro add dynamic is not a part of uSphere component or sync component or anything. It's just like, it's a part of the delegate system. So like, if you look at these delegates, they're horrible. Like, and the way to declare a delegate is even worse. We're gonna look at that in a second, but
is marking a function pressing Alt G the same as clicking on it while holding Control?
Yes, it's the same thing. I think it might be Control clicking might use IntelliSense. I think it does. While Alt Ging is the same as going to quick actions and refactorings, I think. No, it's not bound in here, but it's using IntelliSense. No, not IntelliSense, sorry. Visual Assist Go-To, which is a bit faster and more reliable. I think, I don't know though, but it might be the same. Either way, it will take you there. I will take you there. Okay, so let's see the error. So it's saying bunch of shit. Cannot convert argument 2 from void a def ball void, so that's our function, which is a void function, to void def ball primitive component actor pointer primitive pointer int bool. Okay, so this is the delegate signature, right? Because we're trying to bind our function to the event, but our signature of a function doesn't match what the delegate is. This is what this error message means. I'll just taking the liberty of like interpreting that for you. So the way I will do that then is I will go Alt-G here, and here's the signature, so I will Alt-G to the signature. So just look at what is the signature of the function. Or I would just look in the error message and just copy this. Oops. And this is how you declare delegates in Unreal. It's I know. Just don't look at it too much. So this declare dynamic multiple has sparse delegate 6 params. So saying like, okay, it has 6 parameters. And it's dynamic, which means that you can bind it from blueprints. It's multicast, which means that it's an event and not a delegate. So multicast is the same as doing, instead of typing delegate, you type event in Unity. Sparse, I actually have no idea what sparse means. Probably means something very important. And then delegate is just, this is delegate. And then 6 params means it has 6 parameters. So the way it works is that the first here is the name of the signature. So that's his F component begin overlap signature. So that's the name of the delegate. Here is the class that it's tied to, I think. I'm not so sure with the I'm pretty sure that's what it means. Like this is supposed to be on a primitive component. Then here is what it's called in Blueprint. So this is what's in Blueprint. If you want to bind to this is what it's going to be called. Then here are the actual parameters. It's going to be the type, then the name, then the type, then the name, then the type, then the name, separated by commas. So the type of the first parameter is uPrimitive component pointer, and it's called overlap component. So let's do that. Let's go into def ball here, and I'll just do handle overlap. So the first one is going to give uPrimitive component, and that's going to be my comp. So that's going to be like the component on this actor that overlap with something. So in our case, it will only be the sphere component, but if we have multiple ones, then it will send itself into this first parameter. Then we have an actor pointer to be the other actor. That's not where I wanted to go. No. Take me back. Why is it just competitive? Okay, primitive. So it's going to be an actor pointer. So that's going to be other actor. Cool. Let's close down a bunch of these actually. Then we have whoops. Excuse me. Then we have a primitive component pointer. That's the other primitive component. So that's the component we overlap with. So I will do uPrimitive component other comp. And then we have a body index. And this is if we're colliding with a bone. This will be the index of that bone if we're colliding with a skeleton mesh or something like that. So we won't use this right now, but I'll just type body index, whatever, int32 body index. Whoops. Then we have if we overlap from a sweep, which means like we did a sweep. We swept the actor, and then we overlap with something during that sweep. So we didn't stop, we just overlap with something. It might actually be a stop. I actually haven't tried sweeping with an overlap. It might stop. I actually don't know. But this pool will either way be if we just are overlapping because something moved into us, or because we spawned inside or something, or if it's because something swept into us, or we swept into something. So do from sweep. And if it was a sweep, then the final parameter is the F hit result of that sweep. So so this will contain what the hit was from that sweep. So we'll do const F hit results reference sweep hit. Oh god, we did it. Okay, so that was I hate begin overlap so fucking much. I hate it every time. I never remember, and I have to like look it up. It's so long. Just make it a struct. Just make a struct, please. Okay. So, anyways, so so this is the overlap signature. So let's declare that. So now this should be able to be bound to this overlap event. So now if I compile, hopefully. We're going a little bit over time. I hope that's fine by just a few minutes. We're almost
If
done.
you're ready to take some questions after, it'll be fine.
Yeah, of course. I can imagine you're not like feeling ready to take on the world yet.
Oh, you have no idea.
See, like shaking heads, like people like face palming. It's like unreal, baby. Woo! Oh dear. Okay, so unable to bind delegates. Function might not be marked as a U function. Okay, cool. So thank you. That's at least very helpful. So the problem here is that we are trying to bind to a dynamic delegate. Remember when we looked at delegate signature, it was marked as dynamic. And that means everything that's binding to it has to be exposed to the engine. It has to be exposed and known to the Ethereum engine. And to do that, with the properties, we type the U property to expose it to the engine. Even though it's not visible, it's still exposed to the engine. It knows about it, has data, IntelliSense data, or reflection data. And the way we do that with functions is that we type U function. Like this, no semicolon. So now we're exposing this handle overlap function to the engine. It will generate code to get stuff like reflection data about this function and so on. So that's why we have to type the U function here. If this wasn't a dynamic delegate, we would be able to bind to it raw, which is the add raw. And that means like, okay, it's just a function pointer, no one lookups or reflection needed. But it's a dynamic, so we have to do that. So now let's F5. I fucked up. I changed code while I was let's just stop. let's just start over. It's a good time to take a little break, take a little breather, and recompile. At least it's only 6 files and not 2,100. I remember at the later stages of It Takes Two, I remember our lead programmer, he was chasing down like a shader bug on PlayStation. So what he had to do, because he couldn't test it right away on the PlayStation, he had to go through like the whole cooking process. What he had to do was just like change the core rendering, push it, and then just like wait for tomorrow's build. So what happened was like every day it was like, hey, you guys have to recompile the whole engine and recompile every single shader in the game. So sorry. That was like a week of every day, every morning. It was like, okay, 2,000 files started, and then the engine starts, and it's like 20,000 shaders need to be compiled, and the engine opens up, and it's like, oh, 7,000 more shaders need to be compiled. So that was fun. It was like long time to eat breakfast. Okay, so this is the same bug with I think one blueprint saved weirdly. Cool. So we're in an editor. So now if I do defball, place it in. Now it has a nice default 500 radius, so that's cool. And we didn't get an error, so hopefully it bound correctly as well. So if we play, cool, it works. I mean, we didn't do anything in the function, like the function is empty. Here it's empty. So let's try to log here. So let's do UE log, log temp, log. We'll do actor overlapped. So I will print the name of the actor that overlapped us. So it works like printf, where you type the replacements to be made as percentage sign and then an identifier. S stands for string. So this is going to be replaced with a string, and then afterwards, like you do comma, and then after that format specifier, you type in the arguments to be replaced. So here we want other actor we want its name. So I'm going to do get name. Like so. And that returns an F string. So that's the Unreal's string type. It doesn't return std string or anything. It's an F string. So that's their own string type. They have their own types for everything, I should say. They have the arrays, maps, everything like that has been remade in Unreal Engine. So we get the name. However, this expects a pointer, like it expects a sharp pointer, not like an F string. So we have to actually dereference the string. In std, you would probably do .c string like this. This is how you like dereference a std string, or get the pointer rather to the pointer to the string. In Unreal, you just type a what do you call it? Like a asterisk in front of it. So you do the pointer dereference operator on the F string, and that will give you the actual pointer to the string, like the sharp pointer. So this should work. So let's see what happens. So we compile. Compilation in the nation. It helps us sing a little song while it's compiling. Should probably resave this because of the warning we got. Oh, okay, there we go. Let's see. Play. Ah, cool, there we go. So here we go. It just went through the wall. What the fuck? Where'd it go? Okay, whatever. So we can see here that we're getting a few messages here. So we got like actor BP cool actor 2 overlap. So that was the bouncing boy, and then it overlapped once again. And then here we go. Here we see the overlap with this BP my actor 4, and that's the box here. One of these boxes. I don't know which one, but one of these boxes went into the overlap, so it overlapped with that as well. And then it overlapped with the cool actor 2 times more here. So that's cool. So now we're getting a callback every time we overlap with any actor. So let's do just the last step, and then we'll call it quits, is that we want to destroy this thing when it comes into contact with our sphere. So I'm just going to do... let's just do fucking other actor, destroy actor. Yeah, sure, let's go. Is this destroy? I guess it is destroy, yeah. So we'll just destroy anything that comes into contact with this fucking this ball of death. I actually don't know. I wonder what's gonna happen if we go in with the player. This is gonna be interesting. Okay, so let's see. Ah, there we go. So it like went in really fast and then died. Let's make it go a little bit slower. Let's go make it go like 400. It's like, oh no, please no, and then dies. And then this thing, if I chuck this one in. Hello? Oh. There we go. Fucking get in there. Get in there. Why is it not dying? Oh, there we go. I guess it was starting. It was like overlap by default, so it didn't get notified. I'll send this guy in as well. Nope. There we go. So that's overlaps. That's how that works. And now let's finally go in with the player. So, oh, yeah, there we go. I died. So the camera got stuck. So that's overlaps. Ta-da! Magic.
Hey.
Are you guys impressed with how good this engine is? Isn't it pretty?
It's very engine-y.
That's why I remember when Christer asked me to do the first C++ course for the first year. He said like, oh, I used to do Unreal and C++. And I was like, no. We're not going to do Unreal C++ first. It's like, I think they need a little bit of a ramp to be like, what's a pointer? And it's like, it's complicated. So yeah, that's why I think it's good to do STL first, to be like, what's a pointer actually? What's memory? And then it's like, oh, here's Unreal. It's like, you're ready now. So yeah. Cool. So that's going to be it for today. I'm going to stay for a while and take questions and help you guys out if you want. And then tomorrow at 10, we will just continue doing stuff. We'll do player character or something like that and just see where it goes. I'm thinking by this course, we're going to make a little game. Like we'll come up with some game idea or something, and then we'll just make it for 4 weeks. And I think that will be fun. Hopefully.
Are you gonna share this project so we can take a look at it?
Yes, I will upload this project after we're done here, so you guys can check it out.
Cool.
Sweet. Thank you guys very much. You're a very I gotta say I'm feeling very welcome with you guys. You are great at asking questions, and you're very engaged. So I was very nervous yesterday, but today I'm feeling quite welcome. So thank you very much. You're a great audience.
Good to see you. Nice.
Thank you.
Thank you.
Oh, same to you. I
Thank
think
you.
your meow at the beginning of the day got us all.
It's like, starting with a jump scare, and then it's like it's like anything else is better than that.
Set the bar for what you can say in the chat.
Exactly. That's good strat.
Yeah.
Wait, the meows at the bar and not the naming the entire project fuck.
Yeah, I mean that's just standard. Actually, that's just industry. that's
the standard at Hazelight as well. Then.
Oh yeah, for sure. We name our it's like
cool.
fucking shit and drill bass and.
But in Swedish, then I guess.
Yeah, exactly. It's like fuck,
You gotta start
jävlar, skithål,
You gotta start reverse engineering your
järnspikar.
games to find this.
Yeah, we don't leak our source for a reason.
Yeah.
Yeah,
And that's
so,
the reason, I guess. Yeah.
Yeah, exactly. We will get banned. So yeah,
Wasn't there a game that got? Wasn't it the Spider-Man game that got huge problems there because one of their programmers named a bunch of variable names because he was so pissed at his ex.
Yep.
So
Someone
he had to
like
curse
reverse
violently.
engineering go like, so we found this variable called Deborah's a bitch.
That's cool though. It's like that's how you take out your anger in a adult way.
They needed to do a lot of refactoring.
Yep. It's good stuff. All right, so I'll say yeah. From now on, you're free to go, and I'll just stay here for those who want to ask a few questions. But otherwise, if you guys want to leave, then I'll see you tomorrow at 10. So.
Cool.
Awesome.
I don't want to, but I have to leave.
Oh no, I have to leave soon as well. Actually, so I can't take that many questions. But I'll
We
take.
don't want you to.
Take care. See you tomorrow.
See you tomorrow.
Yeah.
Yeah, thanks a lot.
Bye.
Thank
Bye.
you. Bye-bye.
I have a question.
Yeah.
So from what you said earlier, like it seems like Unreal has a lot of more structural things you have to think about when you like think about code. And you probably work with Unity as well, right?
Yeah, a little bit.
Yeah, and us coming from Unity, like where you can pretty much just throw scripts at anything, and like sure it might not be perfect structure, but it'll be fine. Do you have like any, like it's a very broad and vague question, but do you have any tips for like how we would set that up, especially like we're working cooperatively, like with other programmers?
It's
And especially like short-term projects, because we're like after this course we're gonna have like a 2-week course or something, and then we're gonna have like a 7-week Unreal project. How would we? Yeah, do you have any tips?
I would say my biggest tips is don't worry about hypothetical problems. Would be my biggest tip. That's what I had to sort of learn. That I felt I struggled to make systems because I was always worried about the hypothetical. Like, what if this happens? What if they want to do this? What if Joseph comes in one day, waves his arm, it's like, I want more explosions, damn it! And it's like, oh shit, okay, now I need to add explosions, do that stuff. I was always too worried about that stuff, and I talked with my lead about it, and he told me that you are worrying about hypothetical problems that you aren't having. Solve the problems you have until that doesn't work anymore. So that's what my mantra is nowadays, that I solve the problems I have. I'm like, okay, I want to make this thing. I'm just going to solve the problems for that thing. And when that inevitably changes, it doesn't work, it's not fun, I need to refactor it or something, then I know what the problems are. Then it's like, okay, no, I know why my solution did not work, and I know how to fix it. So then the hypothetical problems I was worrying about, sure, they became real. But when the problems are real, that's when you can solve them, because that's when you know what the problem is. Even if I worried about it and like made every precaution ever in the beginning, in the end I was gonna make mistakes anyways. And then my second tip is never be scared to rewrite stuff. Never be scared to refactor. It's almost always better to make mistakes, like run into a wall and then be like, oh fuck, this doesn't work anymore, and then it's like maybe not start over, but at least like remove the parts that didn't work and solve the new problems that you have, and make systems that solve those problems. And if new problems come in, then do the same thing, repeat until the game happens.
Yeah,
that would be my tip.
Thanks. Another follow-up, I guess. So like designers want to test early, and especially like last project, it was like we had a week of pretty much lectures and coming up with concept, and then it was like deadline, first playable in like 2 hours. Have fun. And then like on real terms, that seems impossible. Would you recommend doing like blueprints at first and then like rewriting it as code later? Can you do easy like translation between that, or
No, there's no easy translation, but I would start if it was like you have to make something in 2 hours, then it's like, okay, fuck. Then yes, I would probably do a blueprint, honestly, just because the recompile times would suddenly become an issue. So then I would blueprint just to test it out. But as soon as it's like, okay, I have more time, I would immediately turn it into code. I would immediately go code, because the more stuff you make in blueprint, the harder it's going to be to transition later. Because there is no easy way to just turn it into code. Like that doesn't work. You have to rewrite it from scratch, basically.
Yeah, and also like sorry for taking up so much time.
No, it's fine.
Like, would you recommend doing like pair programming and stuff like that in the beginning? Like, so programmers are more like, if you're cooperating, like creating the base to build on.
If you want to, I recommend it. It's really good. But as soon as you feel like it's not, either it's not fun or it's not engaging, and you're feeling like a little bit bored, then I would stop, because then it's like it ceases to be useful when you don't want to do it. That's my experience with pair programming. So
okay, cool.
As long as both people want to do it, then yes, then it's great. But yeah, but also you can do like semi pair programming where you both sort of work on your things, and then as something comes up, then you like, okay, come over here, I got an error, let's check it together. You can do something like that. You don't have to be like, okay, sit next to each other all the time. You can do sort of, semi-asynchronous pair programming or whatever. So there's more way to do it, but yeah, it's all about what you feel comfortable with and what you want to do. So it's not
Yeah. That makes sense. Thanks.
Can you theoretically make everything in blueprints, just that it's going to be super non-performance?
People will say you can do it. Like, my teacher Short was like, yeah, I do everything in blueprint. I made the whole game in blueprint. And then it was like, it came out, and he said like, oh, I have a guy in Russia who does like all the engine stuff. It's like, you just outsourced to a guy somewhere else to do the hard stuff, like the save system and stuff. So it's like, okay, great. So you didn't do it all in blueprint then. So no, I would say no, you cannot do everything in blueprint. If you do it, you have to do some severe workarounds and severe mental gymnastics to convince yourself that you're only using blueprints. But yeah, no, I would not say no.
But at least in the beginning, it's good to just prototype it, and then when you realize, okay, this is going to be a big system, let's make it in C++ instead.
Yeah, I would say so. You can sometimes do like envision like this is probably gonna be a big system, like movement is like, okay, that's gonna be a big system, it's gonna be the whole game, so I would probably do that in C++ in the beginning. But there's absolutely nothing wrong with this, like, go blueprints until it doesn't work anymore. Again, solve the problems you have, not the ones you could have. So there's no point in this like only being C++. What if it grows? Then it's like, okay, then when it grows, then move it, instead of just like worrying about it growing. Like, do it in blueprint, it's fine. Sure, you lose a little bit of time rewriting it, but fucking whatever. It's like, it's fine. You'll probably do it better the next time anyways. So yeah.
Cool.
So yeah, don't be scared to get down and dirty in blueprints just because you're coders. Absolutely not. It is coding. Blueprint is coding. It's just different.
All right, can I? Okay, fucking you go ahead, Marcus. I have a doozy of a question. So
okay, sorry. I just wanted to ask you, how would you compare yourself at your current state compared to when you finished your future game studies? Like in terms of what you know now compared to then.
Oh wow. I think the biggest thing is probably humbleness, I think, because when you're the only coder in a school, it's very easy to get a big head. It's very easy to be like, I'm fucking sick. Like everyone wants to have me in their group. Like I can just fix things. I just fix problems super easy. Like I'm the fucking hottest shit ever. And then when you get into the industry, you're like, oh, actually, those people around me are so much smarter than me. Like it's insane. And it's like when you meet someone, it's like, this is like the smartest person I've ever seen in my life. And then you go to the next company and you meet someone who's even smarter. And it's like and then it sort of flips where you go from I'm the best to you go like I'm trash, or like I'm worthless. And that's, the dip you gotta do at some point. At some point in your career, you're gonna do the dip where it's like, okay, I'm the fucking worst ever. Why am I even here? And it's like, the imposter syndrome hole. And then you slowly work your way back up again. So that's the biggest thing I've learned. And I've found that all of the coders who are incredibly talented are the ones who are extremely humble. The ones that are listening, they take your opinion seriously. They are not afraid to help out and be wrong. Those are the coders that I really look up to and the ones I think are the best. Like those are usually the ones that are like the most talented. And another thing I learned is that, things you do in school doesn't matter. I know it sounds a bit pessimistic to say that, but it's like the things you learn from shipping a game are so different from what you learn from, making a game project. Like, since you take the game to 80% done and then you're finished with the project, you don't get any experience of the last 20%. And the last 20% is where the real learning happens, in my experience. Like, the last 20% of a project is like, okay, this is what game development, like, this is another side of game development that I didn't even know existed. Like, these things like optimization and all of those, and like platform integration and fucking all of that stuff. And like learning like what systems are actually good and what systems are okay. Like, you really make that difference. Not that you were able to like only write great systems, but at least you can tell like this system didn't work out well because X and Y, and this system turned out really well because X and Y. And you can like actually have that reflection that you couldn't really have at school. At school, it's like, this one worked out okay. I don't really know why. Like, that's at least what I thought when I went to school. Like, I couldn't really tell really why things went good or bad. So that experience is something you only get in the industry. So yeah. I hope that answered your question.
Yeah, thank you.
Cool.
All right. No one else has a question?
You want to be the last question? You want to
No,
be like
it's just
the
I have
banger?
a bit of a doozy. I know that's not so much about bangers. It is just a fucking just a doozy to get through. And if anyone wants to like butt in before, I would suggest you do it now.
Oh shit! Because see, you're gonna fucking wreck the whole place. Okay, I'm getting some water. I'm ready.
All right. So you said earlier when you said like it's good to use SDL as a ramp before getting into C++ Unreal. Yeah. To someone who SDL wasn't so much a ramp as a fucking brick wall. How do you suggest starting out and actually just getting into this thing? Because I could barely keep. I wasn't able to actually keep up with SDL properly because I never touched C++ before. And this is all very new to me, and I've basically I was basically blacking out every fucking 5 minutes during this whole fucking thing as well. So I basically haven't been able to follow this one either. So, to someone who actually learns better by reading, or are you looking at stuff up via text? What would you suggest looking up so I can keep up with this, what we learned today, and what we're gonna learn tomorrow, and so on and so on? Because I'm not gonna be able to keep up, and with just listening, I'm gonna be blacking out. No matter how hard I try, this is an unfortunate reality.
The thing with learning programming, in my opinion,
yes,
is that no matter how much in the deep end you are, you will never drown. That's what I think of programming. You can be in the biggest fucking hole ever, where it's like, I don't understand anything. I have no grasp of what I'm doing. And as long as you just waddle around there and get used to it and sort of, feel the water around you and feel the pressure, eventually you start to learn to kick your legs. You learn one thing at a time. You're reading through the code. You might not even be reading through anything. You're just typing it. right? And then one thing clicks. And as soon as one thing starts to fall into place, that usually gives you the confidence that it's like, okay, I won't be drowning forever. I won't be in this deep pool forever. I will eventually reach the surface. And then you just keep going. And then you just like, one thing more clicks to place, and then one thing more clicks to place. And then eventually you have an understanding about everything. After like a long ass time, you know? And that's just the way at least I like to think about programming, that it's not about, you know, preparing yourself with like all of the rubber ducks and everything in your body and then jumping in and then you're safe. It's about just like you jump in a pool, you don't know how deep it's gonna be, you jump in because you think it's interesting, and then you just work until you're at the surface, and then you go to the next pool and you jump in. That's how I like to think about programming, at least. So my tip to you would be to be like, try to keep up as much as you can. You know, listen as much as you can. It's okay if it doesn't make sense. Like I don't think that many people. I would be surprised if the majority of this class understood like anything about what I was doing. It was just like, type U function, don't think about it. It's like, you know, that's just what I do, because I am collectively pushing you down into a pool where it's like, you'll be fine. It's like, don't worry about it. And then it's like, we're together just gonna be waddling around in this pool for a while until like maybe one guy pops up really fast and then another guy pops out after a while, you know. But we're all sort of at our own rate racing to the surface, but no one is gonna drown in the pool. Like the worst thing that can happen is you say, oh, this is not my thing, and you don't do it, and that's fine. Like it's okay to not want to do a thing. You just get out of the pool and jump in another one. But it's easy to get into the mindset that if I don't follow along, I'm doing something wrong, and I'm just like fundamentally not understanding something, and that's just not true. That's what I think.
That was a beautiful answer.
Yeah, cool. Thanks. I actually really needed to hear that. Thanks.
Yeah,
Yeah.
that was
Fucking
really inspirational.
philosophical, baby.
Yeah, like that baby bird.
Yeah, exactly.
Mhm. But yeah, that was a beautiful answer. I really do appreciate you just putting my mind a little bit at ease. Still doesn't help me too much because I literally do black the fuck out, as in you talk, and then I realize it's either been 5 seconds, 50 seconds, or 5 minutes. I don't know how much time has passed, and I don't know what I've missed. That's my problem.
Are you like Memento, or do they have like post-it notes? It's like, what's my name?
Legitimately, that's fucking scares me, because I will be gone for a while if I'm trying to concentrate with someone like listening for too long. That is legitimately what happened to me when we were learning about like quantum physics in fucking gymnasiet. Like, I'm going to try, and I'm noticing I'm slipping. I'm going to try really hard to focus and listen to what they're saying. Why did I just open my eyes? I don't remember closing them.
Yeah, I've been.
Yes. So that's what I say. Like, I need something to like start reading, or like, this is not just so much like the philosophy of like, I feel like I can't do this. This is legitimately, I need to get this input. I need to find a way to give myself input that will actually stick, not go in one ear and out the other. Like, and that's what I asked. Like, is there something to read, or is there like some keywords I can like Google about for like, especially like specifically maybe like this start, because otherwise it's just going to be, I can't even copy along at the same time, because when you've done it, then like just like a small mistake, you have to go back. Has been enough for me plenty of times to like drop the ball and not be able to realize like, oh, where did it change it? Where did it like? I can barely keep up with video tutorials. I fucking run around in forum posts instead, because text doesn't move when I don't like.
It's relatively stable.
Yeah, look, I'm very happy that I'm not dyslexic, because like I'm very happy the texts, like the letters stay where they are. Because when it comes to video, that motherfucker will keep talking when I'm still stuck in that one fucking letter or something, and then I have to tell him to pause, and then I'm all out of whack. So that's the like more concrete question. Like, what are some fucking keywords I can put into Google and start reading about? Because otherwise, I am lost.
Yeah. The thing I do, I shouldn't try to relate too much, because I can't say I'm in the same seat as you. I would say what I can do for you is that, of course, I'm recording this, so you can watch back, even though that might not be the most helpful thing ever. I can also try to maybe be a little bit slower when I'm talking. I'll maybe do a poll later to see like is it going fast, slow. It's hard to know when I don't gauge the general audience. But of course, I won't be the exact correct speed for everyone at any point. But what I like to do, maybe that's helpful, maybe it's not, is to look up one thing at a time. To be like, okay, I've copy pasted a bunch of code in my. Usually type it out. I like go to like maybe I'll go like spawning a component UE4. Like I'll do that C++. Oh, not at runtime. Oh, whoops. I'll do like. Yeah, I'll type the name. I'll do like the create default sub object. Here you go. And look at this. Okay, this was not helpful. Get me some. Shit. Okay, so here's some code, right? Okay, this wasn't the best code ever. Well, I'll find some snippet of code that's like, okay, here's what you want to do. So I'll find some snippet of code, and then I'll type it out one line at a time. And as I'm typing it out, I am Googling everything I don't understand. So in this case, it would be like, maybe I don't understand. What's this text for? Why am I typing text in parentheses this root component? And I will try to figure out what this text means. So I'll try to figure that out. And then it's like, okay, if I don't understand what a template is, like what is this crocodile mouths here? What's that? I might Google what's templates in C++, and I will get that survey. It takes a fucking long ass time because you go every single step. I have to stop and I have to look it up, and I have to take another step and I stop and look it up, and it feels like I'm going nowhere, and it's like I'm gonna be stuck here forever. And again, you feel like you're drowning, but that's the thing. You will never drown. You just take one like step at a time. So it's like, okay, eventually I might understand this whole line. I might understand. Okay, I understand every step. At least maybe not understand, but at least kind of. I have touched every part of this line. I have touched what text is. I might not remember it. That's fine, but I have looked it up. I am conscious that text is a thing. And that's the important part. Maybe next line is text again, and I don't remember what exactly it was, but I have touched this, and I have surface level knowledge about maybe what text does. I know it's not scary, it's familiar. And then next line will be a little bit easier. It will be like, I know what templates are now, it's a little bit easier. I go to the next line, it's a little bit easier. I go to the next line, and eventually I might have the whole file down. Maybe not good enough. Maybe it's like I have to do that 2 or 3 times, like rewrite everything. I did that with OpenGL. I remember when I learned that I had to rewrite like the triangle program like 5 times. So it's like I wrote it, didn't understand it good enough, did it again, didn't understand it good enough, I did it again. Like you just kept making mistakes. I kept having to look up stuff, and I redid it again. So maybe that's something that could help you. That sort of way of learning things.
That does, but that's basically how I learned C# when I was still coding for Unity back when I was in Forspace. Just what does this thing do? Yeah, so I think what I would need most from you, I think, is like what we learned today. What would you say like some of the points we learned today? Not even all of them, but just some of the like biggest ones, like how to spawn an actor or something like that. Just those keywords, and so I could just be able to then like hunt for information about them as well. Because otherwise, it just becomes this big sea of where do I even start?
Yeah,
which is a big problem. So you just be knowing like what was it that I missed today? Like what was it that we tried to learn today? Or like something like biggest ones, even like not even everything in it, just these very much basic ones. Like what are these keywords, these points that I which I can then start to use for like by like going out to the net and looking at your code, and basically and you're like, okay, this thing, what the fuck does that do? And then I'm doing everything. But like I need some structure to start off on. If I could do everything like from nowhere, like just start going from nowhere, I wouldn't need school. But unfortunately, I would be the perfect citizen in a fascist society. I need someone to tell me with their whole hand to go somewhere and do something to get started. So that's why I'm here.
So, okay, let's do this. Every time that you feel like you are lost and you don't really know what to do, what to look up, I want you to type to me on Discord, and I will post some links, and I will sort of try to get you the resources that you need to sort of Google up on what we've done. So And I think that's good for everyone, at least. That I'm very open to receiving Discord messages, especially now that I'm doing it sort of full time and not working at the same time. So I'm very I if you want advice on anything, on programming, on this course, I'm very open to at least give my opinion. Maybe I don't know, so I will at least give my opinion. But I'm very open to help, and this is a sort of thing where I would be very open to be like give you pointers, give you some links, something to Google. So that goes for everyone. But yeah, let's do that from now on. That if you feel like you have lost track, then I can give you some links to what you will look up. Think that will help?
That would help me a lot, just because then it feels like, yes, this is the things you want me to look at, so I don't get stuck in, is this really what I should be doing? Yeah. Which is a big hurdle for me. Would those Discord messages be better if they're private or in our big group chat? Because I feel like the group chat would be better because then everyone can take part of it, so it doesn't become like 5 people asking the same question.
Good points. Yeah, type it in there. You can ping me in the group chat, and then I'll do it there. Great. So thank you very much for bringing that up. That's a really good. Really courageous.
No, don't worry. That's basically been happening to me like the last 2 courses. The first course was because we had a shit teacher. The second course we didn't have a shit teacher, and it was still happening to me. So I felt like, okay, now I am the red thread here. So now I have to do something to break out of it.
Yeah, that's good. That is really, really adult of you. I would just be like, I was stupid. I was gonna become a janitor or something, scrub tires. It's like, this is not for me.
That idea has struck my mind a couple of times. Not going to lie.
Yeah.
Return to monkey.
Yeah, exactly. Reject humanity. Return to monkey. Yeah. No, but you are not alone at all. I remember I had a student in the first class I taught, and he came up to me and said like, I feel like there's something wrong with me. Everyone around me seems like they understand everything completely. They can just keep on working. I just don't understand. It doesn't make any sense. And I had to tell him like, I don't think what you think others think is not the truth. And I think people are struggling a lot more than you think they are. It's just that people don't usually be like, I don't understand. Like they keep it inside, like you have been doing. So it's easy to get the trap where you think you are the stupid one, but that's not true.
Thank you,
Emmerich.
Yeah.
Something that you could perhaps try. It's something that I've used both personally myself and that I advised my students to do when I was a teacher. Was that when you're looking at a video or when we're going through something like a lecture as we're doing now, it's like having a notepad up and kind of like typing to yourself what is going on. So like having a inert conversation with the notepad where you go like, so like in text, just explain what happened. Because that is something that actually helped me quite a lot when I was at a point like I kind of lost track of what was happening, and just because then you have a text story pretty much that you can backtrack to see, okay, this is what happened, this is what happened, and this is what happened, and it doesn't need it to be like really.
Sorry, I don't want to interrupt, but are you talking about like sort of keeping like a journal or a diary almost?
Not necessarily like a journal or a diary, but it sort of becomes like that. It's like when
sounds like a loose transcript rather than like typing much down like this happens. No, wait, fuck, this didn't happen. Okay, do this like for word. It's just okay. Now we're trying to get actors to move, for example.
Exactly. Just like very loosely, like okay, now we did this.
Keywords.
Because then I can look up. Yeah, because then I can actually look up how the fuck do I make an actor move, and then if it turns out how do I spawn an actor? Okay, then at least have a rabbit hole to go down through.
Exactly, because you're like trying to type down everything like word for word, like the code and everything. That often takes too much time, and like
that's why I haven't been following, because I can either listen or I can type everything. I can't do both at the same time.
Yeah, so might give that a try. Just like listen, catch the gist of what is currently going on, and then type that down and then continue listening.
Also, like even if you don't actually read it afterwards. Just a act of typing it down can help you remember, because like the more you, because when you're typing it down, you're thinking about it, and the more you think about something, the better you will remember it. Usually, I find.
Yeah, it's like you're becoming active and invested in it.
Yeah,
it really helps.
Also, like the Emil talked about the imposter syndrome thing. Like, it's very apparent with programmers. Like, don't think that everyone understands everything completely, because I was completely lost this lecture as well. Like, I'm in the deep end with you, dude. Like, it's fine, and like, just be like, it's very good that you're saying something, and keep saying stuff when you don't understand stuff, because a bunch of people are in the same situation as you are, and it's super obvious with programmers that we tend to think of everyone else around us like they're the fucking genius programmer that understands everything, and they're the fucking ninja programmer with their keyboard, just like they see like different text everywhere, and it's the fucking Matrix. But that's not reality, right? It's harder to see like how, at what skill levels we are, because it's so broad, like programming, and like you might know something that I don't, and I might know something that you don't. Like, it's very hard. Like, it's you can't really compare in that way, in my opinion.
Yeah, and to add on that, just because someone is doing something differently doesn't necessarily mean that it's better or that they know more than you. It's all in many cases, it's just a direct comparison between like how they learn to do things. So like one person might start making a system in one way, while another one would do it in another way. Both works, like they're pretty much identical in functionality, but both people will look at the other ones and go like, oh, why didn't I think of that?
Yeah, that's kind of a misconception in the beginning of programming, that you're trying to find the right way of doing something. Like, what's the correct way? Like, you feel like there has to be some sort of god way of writing something. And there's better ways than others, but usually, like, when you're in the industry, people will always disagree on what the right way is. It's like, that doesn't stop. People haven't agreed. It's like, okay, now that we're professionals, we do it this way. It's like, we will argue all the time with programmers to be like, no, this way is obviously better. No, this way is obviously stupid. And it's like that.
Tabs for spaces.
Yeah, exactly. Don't even fucking get me started, dude. But
what I've learned is to cheat as much as possible.
Yeah,
cheat the engine.
That's one way of doing it, for sure. I just want to say, I have to dip out really quick, but I just want to say that I just want to add that you guys asking a lot of questions, you're a very interactive audience, which is great, and that's what I want from you guys. I remember the course I did before, I was like typing, and I was like, does this make sense? And no one said anything, and I was like, this does not make sense. Like, don't fucking lie to me. I know that you don't understand this, because this is the first time you've ever seen this. It's like, and it's the same here. When I ask, like, does this make sense? Like, of course you don't have to say like no, but it's like, if you have questions, then feel free to open up. And like, I'm not expecting you to be like fucking like absorbing it like master magicians. Like, I love getting questions, because then I can like sort of explain something I missed, or try to put it in a different way, or stuff like that. And that's what I feed off of. That's what makes me like get up in the morning. So yeah, you've been a great class in that way. Unfortunately, I have to dip. I have to go.
I understand.
But,
by the way, do you understand now why I said I want to ask my question last?
Yeah,
so everyone else could get their stuff.
It was a very good question. It was a very important one, I think, and one definitely I wish I asked when I was in school. But thank you guys. I will see you guys tomorrow at 10, and have a great evening.
Yeah,
bye.
You too.